It may not look like much, but this small experimental aircraft could be the key to allowing airline passengers to fly faster than the speed of sound once again. The XB-1 is a demonstrator and research aircraft for Colorado-based Boom Supersonic. It's the precursor to a new supersonic airliner, the Boom Overture, which is expected to operate by the end of the decade. When the Overture takes to the skies, it will be over a quarter of a century since the crash outside Paris, which doomed the world's first supersonic airliner, Concorde, to retirement from passenger service. The only fatal crash in the aircraft's history was enough to tip the balance on its viability as a transatlantic ferry for the rich and famous. It was a long way from the heady days in the late 50s or early 60s when the concept was first mooted. As costs began to spiral, French and British plane makers decided to join forces in the first major international aviation project. As the 60s progressed, the outlook for Concorde looked rosy, with the order book ever expanding as airlines saw the glamour and prestige of operating supersonic services. However, the design and development weren't as straightforward as first envisioned. Getting an airliner to handle well at landing speeds, as well as twice the speed of sound, pushed aerodynamics to its limits. New engines had to be developed, as well as trim systems to keep the plane balanced when flying almost at the edge of space. With Concorde's first flight in early 1969, it took another 7 years before the airliner had fare-paying passengers in its seats. In the intervening time, fuel prices rocketed, and most notably, the United States banned supersonic travel in its airspace, worried about the sonic boom. The British and French governments wrote off $15 billion of development costs. It meant operators Air France and British Airways eventually managed to make the planes profitable with premium customers and specialist charters. But the crash in Paris and the fall in demand following the terrorist attack on the World Trade Center in New York in 2001 were the nail in the coffin for Concorde operations. Air France and British Airways pulled the plug in 2003, with the last commercial flights at the end of the year, and so apparently ended the era of supersonic airliner travel. In the intervening years, several companies have tried to rekindle the aura of passengers flying faster than the speed of sound. As of mid-2024, 5 programs are linked to building a new supersonic passenger aircraft. So why has it taken so long to get a Concorde replacement?
Over the 20 years since the Concorde has stopped flying, a number of companies, Ariane prior to us, ourselves and others, are working on supersonic flight and trying to mitigate these problems. Both address the issue of economics. How do you fly so it's not so exorbitant to the passenger, that it's affordable? How do you do it responsibly, that it's not producing a sonic boom? How do you lower the emissions? That's another consideration that's becoming a stronger and bigger concern as we go forward.
The two frontrunners, Boom Supersonic creating an airliner to carry 100 passengers, and Spike Aerospace building a business jet to carry about 10 people. The two are taking very different approaches to the future of supersonic travel.
We are finally at a point today, post-Concorde, where both the technology and the market exist to make mainstream supersonic flight really practical. And that's the advent of things like carbon fiber composites for commercial airframes, efficient turbofan engines, the ability to design and iterate on an airplane in computational fluid dynamic simulations rather than through wind tunnels. So at the same time, the growth of international travel. And so we're at a place now where technology and market intersect that enables this to be scalable, not just like Concorde, which was really for like the 1% of the 1%, but something that tens of millions of people can afford to fly on. And ultimately our goal is to make supersonic flight, the benefits to be able to get around the planet more easily available to everyone who flies.
The airliner, called Overture, would travel at 1.7 times the speed of sound, or about 1,800 kilometers per hour. It's certainly slower than Concorde's Mach 2.2, but will still get passengers from New York to London or Paris in around 3.5 hours, about half the time of a conventional jet. As part of the development program, a small demonstrator and test aircraft has begun flying. The XB-1 is made of composite materials, as will the full-size Overture aircraft. The demonstrator will also develop the system to cool the airliner using fuel and a unique camera display to give the pilot a view ahead at the high angle of attack needed for landing. And it incorporates other unique supersonic features.
If you look at our wing shape, it's going to be significantly different than, say, a 787. A supersonic wing looks like a delta configuration or an ogive configuration, and that's done to optimize both the high-speed aerodynamic performance as well as the low-speed stability and handling qualities that are required. So the wing is going to look dramatically different. Additionally, how we feed air to our engines. We can use conventional turbojet turbofan technology that is in use right now on certified aircraft, but we need to slow that air down from the supersonic regime that we're flying in to the fan face at which the engine consumes that air. So if you look at our intakes, they're going to look a lot different than a commercial airplane that you see routinely flying today.
Although the XB-1 is about the size of a fighter aircraft, it's been designed to extrapolate research data to the full-size airliner.
I think maybe the most tangible thing might be both the high-speed regime performance as well as the low-speed handling quality, stability control aspects of the aircraft design. Those are lessons that we can directly apply to the design of Overture.
There's some lessons that are about what works, and there's some lessons that are about what we'll definitely do differently. For example, the ability to create a long, skinny, slippery airplane that also takes off and lands stably. That's the hard part. I mean, this airplane is so slippery. If it fell off a cliff and make a sonic boom on the way down, the hard part is making that same airplane safe for pilots to take off and land and be able to control. And so that's a whole bunch of things that were done on XB-1 that we now know how to extrapolate to Overture. And there are also some things on XB-1 that we were doing differently on Overture. One example is XB-1 has 3 engines, one under each wing, and one in the tail. And it turns out that we've learned we don't like engines in the tail. They're harder to get to. It's a third sort of distinct kind of installation. Whenever we have to do maintenance on the center engine, we can just watch the techs frown because it's a pain to get to, and it's another set of things to design. So Overture goes from 3 engines to 4 engines, 2 under each wing, all of them identically installed, and so that makes for an airplane that not only is easier to design because there's only one inlet, one engine installation to design, but also much easier to maintain with the engines right there under the wing where they're significantly easier to get to.
Spike Aerospace's Diplomat won't be that much bigger than the XB-1. The business jet will try to mitigate some of the concerns of flying supersonic.
We spent a lot of time thinking about how large can we make this aircraft. We would love to be able to fly 100 passengers. There definitely is a market for flying 100 people from London to Dubai or London to Hong Kong. That'd be great. The challenge is if we want to do a low sonic boom aircraft, that size aircraft is just too large and would create a tremendous sonic boom. We were not able to figure out how to do the aerodynamics so that you can lower the sonic boom sufficiently.
But the elephant in the room with all supersonic travel is the loud boom created as the aircraft breaks the sound barrier. The team at Spike Aerospace are working on the technical aspects of mitigating the boom.
The secret is complicated, a lot of aerodynamics, a lot of physics in it, but what you're doing is you're designing the aircraft so the airstream that's coming and hitting the plane is dissipated. The shock wave that creates is dissipated before it reaches the ground. And you do that by adjusting the planform or the shape of the wing. We have a highly swept delta wing, similar to what the Concorde had, but we've changed a few other things to reduce that sonic boom.
Down the road at the XB-1 hangar, they see things a little differently.
So the challenge with sonic boom is a lot more about regulatory than it is about technology. We know how to create sonic booms of a whole spectrum of intensities, But the more we dampen it, the more we give up other things. We give up fuel efficiency, we give up range, we give up affordability of tickets, we give up sustainability. And so to be able to fly supersonic over land, we want to make it quiet enough that it's not a problem for the people on the ground, but not so quiet that it's a problem for the people in the air who then can't afford to fly on it. So there's this sort of balancing of the boom intensity with the economics of the airplane. And where we are today, there is no regulatory framework that says how quiet is quiet enough. And the effort to answer that question appears to be quite a ways off. And so it's not possible to design a quiet boom airplane today because we don't know how quiet it needs to be.
As Concorde showed, saving influential and wealthy passengers hours does create significant value. The question has always been, are those extra hours saved by supersonic jets really that valuable? When Concorde took to the skies, there was no such thing as the internet, so time was money. But nowadays, not so much. And one thing the COVID pandemic taught us is not all business needs to be done face-to-face. However, the Diplomat business jet is aimed squarely at those that need to do business face-to-face and fast.
If I'm going to hire a senior executive, I need to see him face-to-face, touch his hand, have dinner with him, spend some time with him, and that has to be done face-to-face. So the people that are going to be flying supersonic, they still use the internet, absolutely, but they're going to be needing to meet face-to-face to actually do deals, large deals. If you're buying a large asset, you need to see it face-to-face, touch it. If you're doing other deals, if you have supplier or labor strike issues, you need to have a presence there. There are certainly places in the world where you need to have a presence for that deal. And it is not just in business, but also politics. You think of some of the political challenges going on in our world right now. Imagine if we could get somebody there, a leader there that can mitigate that situation.
The philosophy at Boom appears more counterintuitive and inclusive, allowing technology to make supersonic travel available to everyone.
For one, I just want everyone to be able to fly on it, be able to buy a ticket. I don't want this just to be for people who can buy their own airplanes. But for two, 80% of business jet miles are flown over land. And so you could build a supersonic business jet, but if it can't fly supersonic over land, it's not much better. And it has some other trade-offs that make it worse. On the other hand, as an airliner, United doesn't fly the same airplane to Tokyo that they fly across the country. So the notion of a specialized airplane for a specialized route makes perfect sense in airliners. In fact, all airliners are specialized. They already are. And so that makes it's counterintuitive because you think a small business jet would be the best place to start, but it's not. It's actually much better to start with a small airliner, and then that cracks open the whole opportunity to go to larger airliners and then also to go to business jets. And so that's the roadmap we're pursuing. And if you look across history, the people who've tried to do supersonic business jets, they've generally failed. And this is the reason. And this is I think part and parcel to why Boom is the only independent company ever have been able to build and fly a supersonic jet. And that's not just difficult technically, although it is. It's also difficult to get the capital together to go do that, which we wouldn't be able to do if we didn't have a business plan that also made sense.
When Concorde was first conceived in the late 50s, oil prices were low and expectations were high. The dream was for affordable supersonic air travel, but the reality meant it was only for the rich. However, technology appears to have rekindled the dream of flying supersonically at cost that won't break the bank. It will probably be a decade before we know if that dream is a boom or a bust.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.